Hello guys, welcome back to Math Zone African Motives. We are still on our revisions and this is a paper 2 that we are going to consider. That was our mathematics paper 2 common test June 2025. So we are going to consider this from our KZN province. So considering this part, you have got 50 marks and the time frame that was supposed to be 1 hour. So we're going to see, guys, with the time that we have, make sure you go through your instructions and information that is read each and every part you are given, especially your answers wherever it is necessary. You are supposed to round off to 2 decimal places unless stated otherwise. All right, so that is what we have. Considering the first part, question number 1, we are given a diagram. In the diagram below, so this is the diagram that you were given, all right, with the points given. That's a triangle here formed, and we've got the points P, K, R, and N. So these are the points that are being listed also here. All right, these are the vertices of triangle NKR, and we've got the point NP are points on the x-axis and y-axis respectively. And PK is drawn parallel to NR. So the line PK, this line P to point K, the line that is drawn is parallel to NR, this line. These two, they are parallel, all right? From the P to K, you can even indicate that way. It's not a problem. N to R like that. So these two lines, they are what? Parallel. So we are going to consider the properties of parallel lines if it is necessary. So the first question, all right, these are the questions that we are given, which was adding up to 16 marks, all right? 1.1, calculate the gradient of pk for 2 marks, all right? So the gradient, guys, we know this one, it is a direct question that we are given here. We've got the point P and also the point K. The vertices are given P. That point is 0, 2, and the point K is given as what? 4, -6. These are the 2 points that you're given. So you can simply list the points or just label on your points. This is going to be x1, y1. This is going to be x2, y2, like that. So you can simply answer this question to determine the gradient of what? Of pk. We do understand that the gradient, the change in y over the change in x. So that is going to be y2 minus y1 over x2 minus x1. Or if you consider this, we can say the x value at point K, this is the y value at point K, the x value at point P, the y value at point P, like that. So you'll be using this as yk minus yp over xk minus xp. Still, it's one and the same. All right, so substitute that. Y2, that's a -6, all right? So that's -6 minus Y1, which is 2, all right? Over X2, our X2, that is 4, minus our X1, that's a 0 that you have, all right? So -2, -6, -2, that is going to give us -8. 4 minus 0, that's a 4. So at the end, this is going to give us a -2. If you cancel this, you're going to obtain -2 as your final answer. So that is the gradient of this line. All right. Just in case if you are going to use this, you must remember these answers. All right. So this is our gradient of the line PK, which we got as -2. All right, let us move on to the other part. Determine the coordinates, all right? Determine the coordinates of what? Of N, all right? So N is here. That is where our point N, it lies in the x-axis, as we are given also before here that N, all right, and P are points on the x-axis and y-axis respectively. So N lies where? In the on the x-axis. So if this point N is on the x-axis, what is the property that you can use? In the x-axis here, we do understand that y is always equal to 0 throughout this line. Y is equal to 0, which is for the y-axis, x is equal to what? X is equal to 0. If you consider for the y-axis, that is why you see the point P, the x value there is what? That's a 0. The x is equal to 0 throughout the y-axis, and throughout the x-axis, y is equal to 0. So on the point N, we know the y value, that y here is what? It's a 0. That's a 0 that you have there. So what you need is to find the x value. Then you're done. So how can we determine or find the x value, guys? All right. Let us consider what you are given here, or the properties of these two lines. You're told that they are parallel. All right. You are told that these PK and NR, these two lines, they are parallel. And for two lines that are parallel, they have got what? Same gradient. Two lines, if they are parallel, their gradient is the same. M1 is equal to M2. So in our case, the gradient of the line PK that we calculated before, all right, the gradient of the line PK must be equal to the gradient of what? To the gradient of NR. Is this going to help us to determine the value of x? Remember what I said, this is our n here. So what we need here is what? To simply find the value of x. So we can find that. Equate the gradients. Already this is, we have it, the gradient of pk. This is the one that we calculated here, which gave us what? A -2 here. So we can equate that, the gradient of pk, -2. So remember, the gradient, we are going to calculate the gradient of what? Of the line NR, this one, N to R. And from our formula, it is supposed to be the formula for the gradient. Remember here, all right, let me just indicate. So we're just gonna repeat this formula here, but naming our points according to what we have here, it is up to you. You can decide N to be your first point. So you're going to use this as x1, y1. All right. Then R is going to be x2, y2. So let us use that in the formula, y2 minus y1. We are calculating the gradient here of what? Of the line NR. But using the formula for gradient, it is the same. Remember, this is gradient. We are talking about what? Gradient. So that's y2, which is what? -2. For the line NR, y2 is -2. Minus y1. Y1 is what? That's a 0. Instead of you writing y there, no. You know that the y value there for point N is what? Is 0 in the x-axis. So that's -0 over what? X. We move on. X2. Our x2 is what? Is 8. So that's 8 minus x1. Our x1 is the unknown value now, which is the x that we must calculate. So you just write it as what? As x. So you have formed an equation where you are supposed to solve or to find the value of x. You have formed an equation from this statement. That's an equation that you have formed. So simply solve, all right? But before that, we can simplify. Negative 2 is equal to minus 2 minus 0. That's a minus 2 over 8 minus x. Since we have a fraction, let us consider also the other side of the equation as over 1 so that it is also a fraction. And this allows you to cross multiply. So that's negative 2 is going to multiply 8 minus x. Negative 2 into 8 minus x is equal to 1 times what? Negative 2, which is a negative 2. So simply expand the brackets, the bracket that you're given, distribute throughout by what? Negative 2, that is outside. So that's negative 2 times 8, which is negative 16. Then negative 2 times x, that's going to be positive 2x, and that's equal to negative 2. Collecting the like terms, negative 16 to negative 2. So you're going to take it this side. The moment it crosses the equal sign, remember it must change. So it's going to be positive 16. All right. So 2x is equal to negative 2 plus 16. That is going to give us 14. So divide by 2 since we've got a product here. So x is going to be what? A 7. Right? 14 divided by 2. That is 7. So that is the value of x. Find x here so that we can have the point. Remember, we need the point. So that's 7, 0. Remember that y is equal to what? Y is equal to 0 throughout. So that's the point. N is going to be 7, what? 7, 0. All right, that's our point N. So therefore, N is given as x is 7. The y value is what? Is 0 for that point. That is how you can simply attempt or answer these typical questions. As you can see, guys, it was a little bit about your understanding about the gradients, all right? If two lines are parallel, then you must know that they have got the same gradient, same value for the what? For the gradient. So you can use or form an equation from that, because those two, they are what? They are equal. All right. 1.3, determine the length of KR. The length of what? K to R. All right. That's the point KR. All right. So that's the line, I mean. That's 1.3, the line KR. We need its length. Remember, the length is given. If you are determining the length, the formula is going to be x2 minus x1 squared plus y2 minus y1 squared. This is your formula. So simply substitute into the formula. What we need here is k. This is where we've got k, and this is our r here. So we're just going to name our points, all right? Because since we are focusing with these two, that's k and what? K and r. So I'm just going to name this one as my point 1. So that's x1, y1, and this is going to be x2, y2. So substituting into the formula, x2, that is going to be 8 minus 4. So you can even use anyone. 4 minus 8, okay? As long you're subtracting x values together, as long you're subtracting the y values together in the same manner like x2, x1, y2, y1. So you can even use it as x1 minus x2 squared plus y1 minus y2 squared under the square root. It's one and the same. All right, so that is it. Let us have the y values. Y2, that's a negative 2 minus y1, which is negative 6. So that's a negative 6 that you're going to have there. Then we're going to square this. So that is what you have. Negative is going to be a positive. So you're going to have the square root of 8 minus 4, which is 4. So that's 4 squared plus negative 2 plus 6, that is going to give us a 4. So that's 4 squared again, which simply gives us 16 from the square of 4. So that's 16 plus 16, which is the square root of what? 32. So that is our length. The length of KR is the square root of 32, or you can have it in simplest form. The square root of 32 is same as what? 4 square root of 2. You can have it this way, or you can even have it as a decimal. Just press this SD. That's going to give us a decimal, and we can even fix this to 2 decimal places, which is 5,66 units. So you can have it as a decimal as well. You can leave it like this. It's up to you. So that is our length. All right, let us move on to another question. 1.4, if the point T given as k plus 1, 3 minus k is the midpoint of PR. The midpoint of what? PR. Determine the coordinates of T. First, we need the coordinates of T and hence the value of what? Of K. So if we've got the point T, we can simply equate to this one that we are given. So let's find the coordinates of T first. From where? The midpoint concept. We are told that T is the midpoint of what? Of PR. All right, so let us consider that part first. So remember the midpoint formula. It's all about formulas. Geometry, guys, it's all about formulas. All right, so this is the midpoint. That's 1.4. T is the midpoint. We are given that is the midpoint of what? Of PR. From P to what? To R, like this. Like this. So that is the concept. So there is a midpoint which is referred to as what? As T. We do not know where it's going to lie. Maybe it's going to lie here. Maybe it is going to be on this point. We do not know. But that's the condition. So that point T, first determine the point, the coordinates. Determine the coordinates of what? Of T, which is the midpoint. So it's simply, remember that the midpoint, T as the midpoint is going to be x1 plus x2 over 2. Then for the y values, y1 plus y2 over 2. So that's going to give us the midpoint. So it is the midpoint of what? Of PR, P to R, P and R. So we already have the values like x1, y1, x2, y2. So that is what we are going to use. At point P, our x is what? 0 plus. At R, x is what? 8. Remember, we're working with P and what? P and R over 2. The y value at P is what? Is 2 plus the y value at R there is what? Negative 2. So that's a negative 2 over 2 like this. So that's going to give us the point T. 0 plus 8, that's 8 over 2, which is going to give us a 4. Or you can just use a calculator. 2 plus minus 2, that's going to be 2 minus 2, which is 0 over 2. And 0 over 2, that's a 0, all right? So that's our point T. So the point T, from this, we can see that the y value is equal to 0. So if the y value is equal to 0, it means the point T is found on the what? On the x-axis. So that's where we've got the point T, which is what? Which is 4, 0. So the first equation was to determine the coordinates. That's the coordinates of what? Of T, the midpoint of PR. And hence, the value of what? The value of K. So to find the value of K, we can simply use the point T that we are given here. Remember, we are told that if T is equal to this is given what? In terms of what? In terms of K. But here we've got the point T, where we've got what? The numerical values. We've got the numerical value for that. So we can simply equate the two. The t that is given as k plus 1, 3 minus k like this. And this one, they are simply the same. The x value, this is what I'm trying to say, the x value, which is 4, is the same as the x value, which is k plus 1. The y value, which is 0, is the same as the y value, which is what? 3 minus k. So therefore, we can simply say, or hence, it follows that 4 for the x value is equal to k plus 1. It's an equation that you have formed. You simply equate the x values, the one for t, this one, the numerical, to this one, which is given in terms of what? In terms of k. Or you could have formed an equation from what? From the y values, equating the y values of the same t, the same point t. The y value is what? That's a 0. What about here? The y is represented by what? It is represented by 3 minus k. So we can also form an equation from there to say the numerical value, that's 0, is equal to this one in terms of k, an expression 3 minus k. From these two, you're going to find the value of k, and that's a single value. These are not values. So you're going to obtain same value from these two equations, all right? So it was up to you. Which equation are you going to use, all right? From the first one, k is equal to what? Take 1 to the other side. It's going to be a negative. So 4 minus 1, that's 3. 3 is equal to k. So that's the value of k, all right? If you were to use this one, you're just going to take k to the other side. It becomes a positive. So 0 plus k, that's k, which is equal to what? Which is equal to 3. So as we can see, any one of these two, equating any one of these two, you're going to obtain or find the value of what? The value of k. So that was the question. To determine the midpoint, then hence to find the value of k. So you simply equate the two. You are already given the one in terms of k, but you are the one who calculated this one, the point t, from the midpoint concept. So you equate the two. That's how you can simply answer this type of a question. All right, let us consider the other part. Determine the equation of the perpendicular bisector. Remember, when you consider a bisector, that's a line that is gonna, if you give given a line like this, it divides that line into two equal parts. But this one is a special type because it is what? Perpendicular, meaning to say, as it divides this line into two equal parts, it does that at 90 degrees. That's the special property of this perpendicular bisector. The perpendicular bisector of what? Of PR. In the form, all right, this is the format, gradient intercept format of a straight line, all right? So let's consider first the properties of what you're given. They are saying, guys, there is a perpendicular bisector. All right, let me erase this to the line PR. All right, let's go back here to question 1.4. They referred something about PR. PR. On 1.5, we are still on the same line PR. What is it about this line? Before we are told on 1.4 that T is the midpoint of what? Of PR. It is the midpoint. So if T is the midpoint, it means that the perpendicular bisector of PR, it passes through the point T. Where it is, yet it is going to be the point T, because you're told that T is what? Is the midpoint. And the perpendicular bisector is divides the line into two equal parts. So remember, the midpoint is the one that is in the middle, when the line is divided into two equal parts. So from these properties, the perpendicular bisector passes through the point T, where the point T, we referred it as what? As 40. So whatever that you're going to have here as your perpendicular, as a line that is bisecting this line PR. Remember, it is the perpendicular bisector of what? Of PR. The line that you're going to have is passing through the point T. The point T. Because T is the midpoint of what? Of PR. You see advantage, guys, of having these points also taken back to the diagram. Understand, take back to the those points to the diagram. So T is the midpoint. It means it divides this line into two equal parts, the line PR. Not only that, but at 90 degrees, because you're told that it is a what? Perpendicular bisector. Perpendicular bisector. So we are supposed to determine the equation of the perpendicular bisector, the equation of this line, this one that I've drawn. We are supposed to find its equation, this, the one that we are given there. So how can we determine the equation of this line? That is the question. All right, so from this, all right, this is going to be 1.5, right? So to find the equation here, we can see that it is a perpendicular bisector, meaning to say at 90 degrees, the two are supposed to, all right, the property here is that if two lines are perpendicular, the product of their gradients should give us what? A -1. So let's say PR, this one, the gradient of PR, multiply to the gradient of the line that we want, the perpendicular bisector, this one. Let me write, this is our perpendicular bisector. So for the perpendicular bisector, its gradient we do not know, but we know that it passes through the point N, the point T. That is what we only know. That midpoint, the point T, remember, the midpoint. It passes through that point. That is what we know. But these two, they have a special property in terms of the gradients. If two lines are perpendicular, their gradients, the product of their gradients should give us what? A -1. That is the concept. So if we are given two lines that we have, so if we consider in terms of one, let us consider in terms of one line to say the gradient taken from one line. Let's say we are considering M1. It follows that M1 times 1 over its reciprocal, which is 1 over M1, is supposed to give us a -1. So you find the gradient of 1, then you just use 1 over that to find the other one. That is the concept that you're going to use. So if what I'm simply saying is that if one gradient is given as -3, then the other one that you're going to refer, its reciprocal, is the gradient of the other line. It will be -1 over 3. The reciprocal. This is your reciprocal, which you are going to use with a negative there. So the property can be used from any two gradients, any two. So in our case, we are not going to have M1 and M1 like that. We are going to consider now as a single gradient. If you take it like this, it will be a single gradient. But for you to understand, just use what as they are two like that. So M1 and what? And M2. All right. What am I doing here? So what? M1 and M2. Like this. So if you have got one, if you're considering from one, you're considering from one gradient, then you simply have to find its reciprocal. All right. But if you have them, like as we have got here, there are two lines that we have. So we consider the gradient of one to the gradient of another. So in our case, let's take M1 as the one of the perpendicular bisector and M2 as the gradient of what? Of PR, the gradient of PR. So this one, instead, I'm going to write it as M1 times the gradient of PR is supposed to give us what? A -1. So simply find the gradient of the other line. All right, my explanations, guys. All right, do not worry. I'm just explaining some of the other things that we already actually know, just for the sake of revision. So let us consider PR. We never calculated its gradient before. So let us consider that y2 minus y1 over x2 minus x1. So that's P to R there. Y2 is -2 minus y1, which is 2 over x2, that's 8, minus x1, which is 0. So that was going to give us -4 over 8. -2, that's -4 over 8, which is going to give us -1 over 2. This is the gradient of what? Of PR. So I'm saying the gradient of the perpendicular line, the one that we do not know, times the gradient of PR, this one that we calculated, which is -1/2, is supposed to give us what? -1, just like that. So what is the gradient now of what? The line that we want, which is the perpendicular line. Simply divide by what? A -1/2, a -1/2. So that's it. This one and this one was going to cancel. And you have got M1, which is the gradient of the other line. -1 divided by -1/2, that's a +2. All right. -1 over what? Just open a bracket. -1, that's -1 over what? Over 2. Like this, close the bracket. That is going to give us a 2. All right. Let's go back to the normal mode. All right, sorry. That's a 2 there. Just want to go back to the normal mode. Press 8, press 2. So if we're going to do that, that was going to give us a 2, as it is -1 over 2, like this. So this is it, just a 2. So that is the gradient of the perpendicular line, this one, the perpendicular bisector, its gradient is 2. So if we've got the gradient, guys, we can determine the equation. Now we can determine its equation. So that's our question here, the equation of what? The perpendicular bisector. So the equation of a straight line given as y is equal to mx plus c. M is the gradient, which is the gradient of the perpendicular bisector. And that's what? That's 2. So y is equal to m, that's 2x plus what? Plus c. To find, say, the y-intercept, you can substitute the point T, because that passes through the what? Midpoint. It passes through the midpoint, which is what? Which is through the point T. So that's our point T, which is 4, 0 can be used. X value, y is what? Y, that's a 0. So 0 is equal to 2x. So that was going to be 2 times x. Our x is what? Our x is 4. So that's it. You can find the value of c. So 0 is equal to 2 times this. That's 8 plus c. Take this to the other side. That's going to be -8 equal to c. So therefore, our equation is y is equal to 2x plus what? 2x plus -8, which is simply a -8. So that's the equation of the perpendicular bisector from the information that we have. So you simply play around these typical questions. You simply play around the way that you've been taught in class and adding with the information that we have now, just one or two that can help in your revisions. So that was it for this question, having 16 marks, the goal of it. So let us move on to the other part. That was question number 2. And we are given 2.1. In each of the following equations, solve for theta, where theta is greater than 0 but less than what? 90 degrees, meaning to say we are simply dealing with what? Acute angle. Theta is simply an acute between that in the first quadrant, all right? Between 0 and what? 90 degrees. That's an acute angle that is being formed. Give your answers correct to 2 decimal places, right? So let's start with the first one, 2.11. The cos of 2 theta is equal to 0.35. Remember, the cos of the angle, our angle is what? 2 theta. So to obtain that angle 2 theta, this one, to obtain this 2 theta, we must have cos written on the other side as what? Arc cos. So you simply have it as arc cos of what? That, or simply introduce arc cos both sides. Thus you remain with the angle, all right, which is 2 theta, and that's equal to arc cos of what? 0.35. So that's 2 theta is equal to what? Let us find our angle. From this, that's shift, you press cos. That's arc cos of what? 0.35. So it's going to give us 61.51 to 2 decimal places, all right? Let's just set up, fix this to 2 decimal places, 69.51. So 69.51 to 2 decimal places. So to obtain the value of theta, simply divide by 2 as you've got a product. So you're going to simply divide by 2. That's obtaining the value of theta from what we have, 69.51, simply divide it by 2. And since our calculator is fixed to 2 decimal places, it's going to give us a rounded off value, which is what? 34.76. And that's an angle that you have. Theta, this part, it represents the angle. So the moment you introduce arc cos, whatever that you're obtaining is an angle in what? In degrees. So that is the concept. All right. So the first one, that is how you can play around with that concept. Let us consider 2.12, where we have got 3 cot. This is the cot of theta minus 8, and that's equal to 8. That's equal to 0. All right, let us just remain with the cot. All right, the cot here. The cot, all right, we can even change it. We know that the cot of theta was taken from 1/tan. So simply 1/tan. So it's just like 3 times 1/tan of theta minus 8 is equal to what? Is equal to 0. Right? So let us take the negative 8, multiply these two. This is a single term, so you can just combine this, have it as a single term, because 3 is same as what? 3/1. So you can multiply 3 times 1, that's 3 over what? 1 times tan, that's the tan of theta. Then the minus 8, take it to the other side, is going to be a positive. Simply add 8 both sides. So 0 plus 8, that's 8. All right, this is same as over 1. We want to have, or what we need actually is to obtain or to have a presentation for the tan of theta as a single trig. You must have a single trig, a single trigonometry function, a single trig, which is the tan of theta. So you have to solve for that, make it the subject of the formula. So what can we do? Cross multiply. That's tan theta times 8 is going to give us 8 tan theta. 3 times 1 is going to give us a 3. So to find the tan of theta, divide by what? Divide by 8, divide by 8. So that's it. You have got the tan of theta, which is equal to what? Which is equal to 3/8. So once you have got tan of theta, which is 3 over 8. Guys, it is the same as what you had here. The cos of 2 theta equal to this decimal. There is no difference having tan of theta equal to 3 over 8. 3 over 8 is also a decimal. It can be written as a decimal. Remember, 3 over 8 can also be written as a decimal. That's going to give us 0.375. So you can have it as a decimal, or you can use it as it is as a fraction to obtain the angle theta. So theta is simply equal to arctan of what? That's arctan of 3 over 8. You have got tan, so arctan on the other side. That's the idea. So that is going to give us the angle theta. You can use the decimal, this one, 0.375, or you can simply use that as it is 3 over 8, arctan 3 over 8, like this, from your calculator. So that is going to give us 20, comma, this. We can fix it to 2 decimal places, 20.56 degrees. So that's our angle theta now. So that is how you play around with these questions. All right, you see, guys, just solving. So just understand that cot from a tan, we can take it from a tan. It is easier that way because we do not have cot on the calculator. So we have to use tan because we have tan on our calculators. All right. 2.2, moving on to 2.2, you're given to solve, all right, without the use of a calculator. Calculate this, all right? So just calculate this without using a calculator, meaning to say they want us to use the special angles when it is like that. So we've got the cos squared of 45 degrees minus the sine of 30 degrees. When the calculator is not required, simply apply or use what? The special angles. So that's where those angles play a role. All right, remember from our 45-degree triangle, this is 45, this is 45, 1, 1, square root of 2. You must know these ones by heart. Another one was asking, are we supposed to know this one by heart? Yes, the special angles, guys, you must know these ones by heart, these diagrams. All right, so these are the 2 triangles that you can simply use to determine these angles. But even if you do not know, like you've forgotten, use your calculator. Just simplify stage by stage using your calculator, but understand these diagrams as well. All right, so the cos of 45, we can simply, I'm going to use this one since there are 2 of them. So I'm just going to use 1. It's simply going to give us the same answer. All right, according to this 45 degrees, this is our opposite. All right, so this is the opposite side, this is the adjacent, and this is hypotenuse. So cos from our SOHCAHTOA, that's cos adjacent over what? Adjacent over hypotenuse. So it's going to be adjacent over the hypotenuse, adjacent over hypotenuse, 1 over square root of 2. So that's 1 over the square root of 2. But it's being what? Squared. That's the cos squared that you have. So you must square this minus the sine of 30. That's our 30 degrees. According to 30, this is the opposite side. All right, this is the adjacent, and this is our hypotenuse. And the sine is opposite over hypotenuse. So opposite over what? Hypotenuse, 1 over 2. So that's it. So this is where you are. 1, you square it, 1 squared, that's 1 over square root of 2 squared, guys. A square root, then you square it. Remember, this neutralizes, so you remain with what? A 2. Minus 1 over 2. These 2, they are the same. A minus A gives us what? A 0. So 1 over 2 minus 1 over 2, that's a 0. So that was the concept, all right? That was the concept. You're simply going to use the special angles. All right, that was it. Then 2.3, you're asked also not to use a calculator. So you're going to use those, we're going to need those special angles where it is necessary. But let's see if it is necessary. They are saying here, if 2 sine theta minus 1 is equal to 0, and theta is taken from 0 to 180. That's in the first quadrant. That's an acute angle. So actually, with the aid of a diagram, this is going to be found in the first quadrant like this. So we're going to need theta. So in order for us to have the ratio presented, whether it's opposite, adjacent, hypotenuse, this ratio must be taken from this equation here, the statement. So let's form 2 sine theta minus 1 is equal to 0. Let's form the ratio, and that ratio is going to be for what? Sine of theta. That is the one that we need to use here to fill in our diagram, because we are told that we must use a diagram without the use of a calculator. So let's fill in from what we are given. This statement, use it. All right. So find or solve sine theta. Find what sine theta represents as a ratio. All right. So what can we do? Get rid of the negative 1, take it to the other side. So it's going to be a positive 1 there. All right. Or simply add 1 both sides. 2 sine theta is equal to 0 plus 1, that's a 1. To find the sine of theta, divide by what? Divide by 2. So that's the sine of theta is 1 over what? 1 over 2. Remember the ratio of our sine from the SOHCAHTOA concept. The sine of theta is opposite over hypotenuse. So this represents opposite over hypotenuse. And thus, according to this right angle triangle, according to theta, this is our opposite. And that's our hypotenuse. So meaning say this is our adjacent. So opposite is what? It's 1. The opposite side is 1. The hypotenuse is what? The hypotenuse is 2. This is what we have. So when the opposite is 1 and the hypotenuse is 2, you can simply see that this is the triangle that we had, something like this here. When we have got opposite 1, hypotenuse 2, the other side is going to be what? Square root of 3. This is going to be square root of 3. So it is actually taken from the angle of 30 degrees. This theta here, by just knowing this triangle, as you can see, when opposite is 1 and hypotenuse is 2, and this is what? This is going to be square root of 3 from this one. Or you are going to calculate it from what? From the Pythagoras theorem. R squared, hypotenuse squared is equal to this, so R squared is equal to X squared plus Y squared. So meaning to say your R is 2, 2 squared is equal to X. You want to calculate X plus Y squared. All right, so 4 is equal to X squared plus 1. That's to the other side is going to be a 3. 4 minus 1, that's 3, equal to X squared. Introduce the square root both sides. It was up to you. So square root of 3 is equal to X. So as you can see, that's the X value, square root of 3. Or by just understanding this, you see now the advantage of knowing your special angles. By just knowing that there's a 1 and a 2 in the in this format, you know the other one is going to be square root of 3. And for that angle, it means this is where our 30 degrees is. The other one is going to be 60 degrees according to what we have. But in this case, there's no need for you to even write that angle to say it's 30 degrees, because you are being asked this not in terms of the angle, but in terms of theta, tan theta, this and that. So there was no need of you finding or taking us that this is going to be 30. No. Yes, if you want, you can write it like that. So let's answer, guys, 2.31, the tan of theta. So the tan of theta from that SOHCAHTOA concept, guys, how did I erase that one? Because I need it. So that's opposite over adjacent. To find the tan of theta, we are going to need opposite over what? The adjacent. Opposite over adjacent, which simply means the y value opposite. These are the y values. The adjacent, these are the x values. So that's opposite, it's 1. Adjacent, that's square root of 3. So you can leave it like that, or you can simplify it further by rationalizing. It's going to square root of 3 over 3. If you multiply by square root of 3, both numerator and what denominator, or just leave it like that. All right. Then 2.32, 1 over cosec. So it's 1 over cosec theta minus 2. All right. Remember cosec, when we have got a cosec, all right, let us just have it here. The cosec of theta is taken from 1 over the sine of theta. So now the moment you have it as 1 over this, it means you're going to have 1 over that. And 1 over this is the reciprocal. And the reciprocal of 1 over sine is going to be what? The sine of theta. So the 1 over cosec of theta is going to give us sine theta, all right, minus 2. So find sine theta from this. Sine is opposite over hypotenuse from the SOHCAHTOA, opposite over what? Hypotenuse. So our opposite is 1, hypotenuse is 1, or the y value over the hypotenuse, which is our r, right? So that's it. Or just simply 1 over 2, opposite over hypotenuse. So that's 1 over 2 that you're going to have from there, minus what? Minus 2. So that is what you're going to have. The minus 2 is already part of what you're given. So simply subtract that. All right. So let us simplify and see from what we have. Even here, guys, you can even just use a calculator here, guys. It's not even a problem for this one. 1 over 2 minus 2. All right. Just for the final answer, that's negative 3 over 2. Negative 3 over 2. All right. For this one, you can just have it like that because it's already 2 marks. The final answer, just 1 mark for that one. So that is how you can play around with these questions. So that was it, guys, for 12 marks, the whole part of question number 2. Let us move on to question number 3. 3.1, complete the following statement. The adjacent angles on a straight line are the adjacent angles like this. On a straight line, they are what? They are supplementary. They add up to 180 degrees. Remember that. They are supplementary. Those are adjacent angles on a straight line. They are supplementary. They add up to 180 degrees. So using this diagram on 3.2, in the diagram below, we are given the angle MRX, which is the angle R, this one, 5x minus 40, ERC, which is B, the angle A, everything, right? Use the diagram above to determine with the reasons the following. 3.21. Calculate the value of what? The value of A. So the value of A here, remember these two guys, they are on a straight line, and we've already talked about what? The adjacent angles on a straight line, that they are what? They are supplementary. So you can simply use that to determine the value of A. Angle A plus what? Plus 100 degrees is supposed to give us 180 degrees. Those are adjacent angles on a straight line. So we're talking about what? Adjacent angles on a straight line. Just gonna write in short. Remember, they add up to 180 degrees, those angles. So you can find the value of A, take that 100 to the other side. So it's going to be 180 minus 100 degrees, which is 80 degrees. So that's our angle A was going to be 80 degrees. All right. Let us move on to another part. Write down the value of B in terms of X. The value of B here in terms of X, all right? B and 5x minus 40 are also on a straight line. So we can find that B in terms of X, all right? So that's 3.22. Angle B plus this one, 5x minus 40 degrees as a combined expression is supposed to give us 180 degrees. Why? They are also adjacent angles. So we've already specified this reason. Those are adjacent angles on a straight line. Adjacent angles on a straight line, they add up to 180 degrees, remember. So you can find B in terms of X. Simply take this expression to the other side of the equation. So it was going to be 180 degrees minus, what are we subtracting? This bracket of 5x minus 40 degrees. So that is going to give us B, 180 degrees minus, simply expand the bracket, distribute by that negative. So that's negative 5x, negative times negative, positive 40 degrees. So to find B, as we are going to consider the like terms, simply add 180 plus 40 degrees. So if we add, that is going to give us 220. 180 plus 40, that's going to give us 220 degrees. Minus what? Minus 5x. So remember, that's an expression that we are having there. So we've got an expression in terms of x. It means that's an expression. So that's our angle B. And 3.23, it is actually verifying that if this angle B that you're given is 220 degrees minus 5x, then prove that RC is equal to RX. We are supposed to prove that RC and RX, they are equal. We must prove it. All right? We must prove that those two, they are equal. How can we prove that these two lines, they are equal? We can only prove it, all right? Remember, we are told that B is what? 220 degrees minus 5x. So what is the property, guys? You just use this concept here to say, if two lines here are equal, then the opposite angles, they are supposed to be what? Equal. These two angles must be equal. So in order for us to say these two lines, they are equal, let us prove the angles. These two angles are supposed to be what? Equal. That is what you simply have to prove. The angles opposite to these what? To these lines. The angles opposite must be equal. Once you can prove that these two angles here, they are equal, you have proved that those two lines, they are what? They are equal in length. So what can we do in our case? All right, let us simply find angle X for in triangle. I'm going to work with the triangle 3. All right, that's 3 point what? 3.23. In a triangle RCX, I'm going to use that triangle, right? We have got angle X already calculated as given. We calculated this 80 degrees. Angle C is equal to 2x. And angle R is given as this 220 degrees minus 5x. This is the angle represented there by what? By B. These angles must give us 180 degrees. Angle R plus angle X plus angle C supposed to give us 180 degrees. We are talking about angles, sum of angles in a what? In a triangle in this case. Sum of angles in a what? Triangle. So if we were to add these angles together, the angle R, which is 220 minus 5x plus angle X, our angle X, which is our A, which is 80 degrees, plus angle C, which is 2x. This is supposed to give us 180 degrees. That's why we have formed an equation where you can solve for X. Why solving for X? Because we want to prove that these two angles are equal. This one is given in terms of X. So if we've got the value of X, we are simply going to multiply by 2 here. 2 times X, 2 times that answer. Then we can see if these two are. So the issue must be on the numerical values there. That is what we simply need. So we must find what? We must solve for X or find X. All right, let us solve collecting the like terms. In our case, we've got these 220, 80 degrees. Add those angles together. That was going to give us 220 plus 80, that's 300 degrees, minus 5x plus 2x. Those are like terms, so that's going to give us negative 3x equal to 180 degrees. minus 3x is equal to what? Take the 300 to the other side of the equation, so it's going to be a negative. So that was going to be 180 degrees minus 300 degrees. Minus 3x is equal to, this is going to give us negative 20, negative 120. Divide by negative 3. By negative 3, you're going to have the value of x, which is going to give us 40 degrees. So we have x. What about angle C? Angle C is given as what? Angle C is given as 2x, 2 times x. Our x is what? 40 degrees. So if you multiply here, you're going to obtain what? 80 degrees. So guys, we can see that these two angles, they are what? They are equal. So if these two angles are equal, it means these two lines are equal. The lines opposite those equal angles, they must be equal. So therefore, we have proved that those lines are equal. From that concept, it simply tells us that RC is equal to what? To Rx. Why? These are sides opposite what? Equal angles. From equal angles, the sides opposite are equal also. So those are sides opposite what? Equal angles. Sides opposite equal angles. That's what you can actually have as a reason. All right, you can just put that one as a reason to this part. So that was it for this question. In order for you to have the total of 9 marks on question number 3, you had to consider these properties very much. Know the properties, guys, the basic properties in actual sense. It is just the basic properties. Know your properties. Let us move on to question number 4. It seems like we have got it here. All right, question number 4 here. We are given that on 4.1, TPQR, all right, TPQR, this one is a parallelogram, and you've got these lines, parallel, this and that, and using the diagram above, prove the theorem which states that the opposite sides of a parallelogram are what? Equal. Opposite sides of a parallelogram are equal. All right. So it is either I'm going to prove that TR is equal to PQ. It's either I'm going to prove that TR is equal to PQ, or we are going to prove this PT and QR, or TP and whatever that you have there. PT is equal to what? QR. That is what you must prove. That is what they are saying. Opposite sides of a parallelogram are equal. So what can we do, guys? How can we prove from this? So you can choose 2 triangles to work with. Then prove the congruency concept, because we do understand that from congruent figures, that's where we can tell that the sides are equal or not. So which 2 triangles can we work with? We can work with this bigger one and this other one. These 2 triangles that we have, PTR. Let's just have triangle 1, triangle 2. In these 2 triangles, all right? That's our question 4.1. So in a triangle PTR and triangle, we're going to have another one, RQP. Let's find or formulate congruent figures. Because congruent figures, those are the ones that we know that it's exactly the same. Because we want to prove something equal, so it must be exactly the same. So PTR and this one, we want to prove the congruence. All right. So what is it that we have in this condition? One, we can consider the angles from the parallel lines. all right? If we consider parallel lines, before that, we are told that it's a parallelogram. So angle T and angle Q, these ones, they must be equal from the properties of a parallelogram. We can consider that. Another part, T, P, R, this angle here, and PRQ, this angle here. We can consider that from the issue of our alternate angles where we form a Z from our parallel lines concept, all right? So let's start with that one that we've got properties that we can have from parallel lines, all right? So in triangle PTR, the angle is what? The angle is P. Angle P is equal to, in a triangle, in this one, the angle is what? Is R. So it is equal to angle R. From alternate angles, we are forming what? A Z. Those are alternate angles that we have there. Alternate angles. Since these two lines are parallel, since TR is parallel to what? Since TR is parallel to this, all right, the alternate angles here, it's not about TR, it's about these two, PT and RQ. It's about these two lines, this one, PT. PT is parallel to RQ. Be very careful about that. All right. So these two, it's part of congruence. Let's move on. Another part that we can actually have are the angles T from this one, TRP, this one. TRP, then RPQ, alternate angles again from what? These two lines that are parallel, this time from TR and PQ. So we can actually consider that. So angle from triangle PTR, the angle is what? R. Angle R is equal to angle P. Take note, guys, they are from different triangles. This is for here, this one, and this is for this triangle. So you might see as if we are repeating the same thing. No, it is not a repetition. It's they're actually different from the sense of the triangles. It's from which triangle. And this one is taken because TR is parallel to what? To PQ. That's the reason why we are taking these alternate angles. All right, so we have got angle, angle. What else? We can see that PR is a common line. So PR is actually common. So congruence can actually be taken into consideration from that part that we have. We can simply name the two triangles that are congruent as what? PTR, PTR, all right? Being congruent to triangle. All right, so it's gonna be the first one, PTR. You take it in that manner, but the second one must be taken properly now according to this. P, we said P and what? P and R. P is equal to R according to these angles, according to these properties, all right? Then the T and the Q. Remember those properties that I was saying for a parallelogram. This is an obvious case that opposite angle. So that one, T and Q. Then R, this R and P, this R and P, this R and P, like that. So these two triangles, they are actually congruent. So if they are congruent, let's figure out now to say that opposite sides of a parallelogram are what? Are equal. The opposite sides, we have got TR and what? PQ. Do we have that? It must be in that order, in that manner. All right, so let's prove that. Here is what we have, TR. QP, TR and QP. In that, let's check the last two. So that's what we have. Therefore, TR is equal to what? QP. Those are opposite sides, isn't it? Let's check where there is PT. P to T, this one, PT must be equal to RQ from this. So you can see that PT is equal to what? To RQ. And PT and RQ, these are opposite what? These are opposite sides. These are opposite sides. So therefore, these are opposite. So hence, we are saying those hence opposite sides of a what? Of a parallelogram, all right, of a parallelogram are equal. So that is what you can actually put into consideration from that. Once you can have this, you can have it in any other manner that you want. So that is it. Let us move on to 4.2. And we are given a diagram here. ABCD is a square. ABCD, this one, it is a square. So remember, square, all the given sides will actually be equal, and the angles will be at 90 degrees, 90 degrees, 90 degrees, 90 degrees each, all right, from the properties. And we're given that diagonal AC and this line BGE intersect at what? At G. All right, angle EBC is 40 degrees. This one is 40 degrees. All right, so that is what you're given from this. That is what you're given, guys. Calculate with reasons on 4.21 the size of A angle G1. So this angle G1, this one. How can we determine the angle G1? All right. With this information, one, in a square, the diagonals bisect at right angles. That is what we know actually. So if we are to consider, let's say there was a diagonal here, we know that these diagonals bisect at what? At 90 degrees. But for now, what can we use? What can we actually use? All right. We have 45 degrees here, so it means also this diagonal, all right, these diagonals, they bisect these angles. Remember, these angles are 90 degrees, so it will be 45, 45, 45, 45 degrees, right? So what we can actually use, we can use a lot of things, guys. We can use a lot of things, all right? Let me use this one. There's gonna be a lot of things here, a lot. So choose which one that you want. But according to this, we can find this angle here, this angle that you see, which is BGC. It is equal to angle G1. They are vertical opposite angles. All right. So 40 degrees is given. This angle EBC is equal to 40 degrees, sorry, 40 degrees given. It's already given this one. Then we said angle C1 and C2, those two are equal from the line bisector. So angle C1 is equal to 45 degrees from the line bisector. Diagonal bisects the right angle, all right? So diagonal, that's diagonal. Just gonna write in short, diagonal bisects the right angle. All right, the right angles or the right angle like that. So this will be 45, 45. So if angle C1 is 45, angle EBC, this one is 40 degrees, we can determine angle BGC. Angle BGC, which is equal to angle G1. Those are vertically opposite angles. Remember your vertically opposite angles. So we can find this angle BGC from where? From angles in a triangle. They sum up to 180 degrees. So we can simply use that. From 180 degrees, we subtract the 40 degrees, which is the angle EBC. We subtract that, and the 45 degrees, which is our angle C1. So we subtract these two from 180 degrees because we know that that's from what? Sum of angles in a triangle, they add up to 180 degrees. So that was going to give us BGC, which is equal to angle G1. All right, remember BGC and G1 vertically opposite angles. So that was the idea. 180 degrees minus these two. Let's first have our calculator back to the normal mode. So that's 180 minus 40 plus 45, like this. And that was going to give us 95 degrees. All right, so this is 95 degrees, just like that. So that will be our angle G1 from that information that we are given, All right, any other way that we could have used, these ones as alternate angles. All right, these two lines, they are parallel. So those will be alternate angles, meaning to say the angle E, this one, the angle E was going to be 40 degrees. Then you can simply use angles in a triangle like this. So you can see that you are simply going to obtain the same 95 degrees from that idea. So that is how we play around with this part. And another way that we could have worked it from was to calculate angle B1. Angle B1 is going to be 50 degrees, 90 minus 40. Then you calculate this one, this G here. It's going to be 45 plus this, which is 90 what? Guys, did I subtract properly? 45, right? Is there anyone that is it, 180 minus 40 plus 45. All right, because here is gonna give us 45. Let's see what's happening on this one, guys. It's 45 plus 45 plus what? 45 plus 50. That is going to give us 95 degrees. And that 95 degrees from 180, all right, from 180, or simply 45 plus 50 is going to give us 95 degrees, which is the the exterior angle equal to the opposite, what? Equal to the opposite interior. That's another way again. Yes, it was going to give us the same. So, guys, there are so many ways that we could have determined that angle G1. So it was going to be so many ways. You can use this. You can use that one that I explained from this triangle 45 and 40. Then you find the third angle. You can use the 45 and the 50. Then you consider the exterior angle of what? Of a triangle equal to the opposite interior, the sum of the opposite interior. So just write the reasons for each part that you are using. But as you can see, that is what you're going to have. Then another part is angle E, the size of angle E, All right, the size of angle E. So if you have used that one, you have already mentioned about the angle E here. Those are what? equal alternate angles, all right? So angle E is actually taken from alternate angles, or you can use it from angles in a triangle. Let's say we've got this 95 angles in a what? In a triangle. So many ways, guys, to find angle E. All right. So that was going to be part B. So angle E, I can simply say it is equal to 40 degrees. Those are alternate, this where we are creating Z alternate angles. All right. Alternate angles. You can actually use that because we know that in a square, these two, a square is a parallelogram, remember. So opposite sides are parallel. We do know that from the properties of what? A parallelogram. A square is part of what? A parallelogram. So those are alternate angles. Since AE is parallel to what? To BC. That's another reason that you can actually have so many ways, guys, or so many reasons that you can actually use to attempt that one. All right, then the last one was 4.22 in if AB is square root of 2, if AB is square root of 2, A to B, all right, let's see. If A to B is square root of 2, and DE is equal to X. DE is equal to X from D to E. It is equal to X from that D to E. All right. Then what are we supposed to prove here? Show that BE is going to be given by this. Show that BE is equal to this. That's 4.22. All right, BE, BE, BE. Let's see what is happening here. B to E, this is our BE. All right, this is simply, guys, a right angle triangle. We're seeing that. So that's 4.22. BE is the one that we must prove. And it's a right angle triangle that is being formed if we are using this triangle ABE. In a triangle ABE, all right? In triangle ABE, we are forming what? A right-angled triangle ABE, where AB is what? Square root of 2. Where AB is square root of 2. But we are given from D to E as we need to find the whole of this line AE. So what is that we can use? AD, remember this is a square. So AD is equal to AB. AD is equal to AB, which is also the square root of 2. Those are sides of what? Sides of a square. Remember, for a square, those sides or all sides are equal. So if AD is a square root of 2 from A to D, if this is square root of 2, what about the whole of this line from A to E combined? From A to E combined, it will be square root of 2 plus x, or x plus what? X plus the square root of 2. It's going to be x plus what? Square root of 2. You add these two combined. So this is the right angle triangle ABE. You have to combine square root of 2 and x. This is also square root of 2. This one is also square root of 2. For a square, all sides will be equal. But there, you have to add to form this A to B to what? To E. A right angle triangle formed. You must have the whole of this side. So the question is to find BE. In a right angle triangle, guys, BE is what? Simply hypotenuse. So we can find it BE squared, or from our Pythagoras theorem, the hypotenuse squared is equal to the square of the shorter sides AB squared plus what? AE squared in this triangle ABE. So that's BE squared is equal to AB. What is AB square root of 2? You square it plus A to E, from A to E, that's x plus square root of 2 being squared. So that's our Pythagoras theorem being used there. All right, from what? Pythagoras theorem. Pythagoras theorem. So let us solve for BE in terms of what? In terms of x. All right. Square root of 2 squared, a square root and a square neutralizes, so you remain with what? A 2 plus x plus square root of 2 squared. We've got that binomial expansion, a plus b squared equal to a squared plus 2ab plus 2ab plus b squared. Or you can simply have two brackets, x plus square root of 2, x plus what? Square root of 2. Expand them or simply use this concept. So this is our a and this is our b. Where we've got a squared, it means x must be squared. So that's x squared plus 2ab. That's 2 times our a is x. Our b is what? Square root of 2. So 2 times square root of 2 times x. You put that x aside. All right. Plus b squared. Our b is the square root of 2. So square root of 2 squared gives us a 2, just like here, square root of 2 squared gives us what? A 2. So that's a 2 that you're going to have here. All right. So let us consider simplifying, collecting like terms. BE squared is equal to, also from the algebraic, this is x squared. I'm going to start with the highest power, x squared. So that's x squared, sorry for that, plus 2 square root of 2 x, 2 square root of 2x. Then considering the constants, there is 2 and a 2. So 2 plus 2, that is going to give us what? That is going to give us a 4. So that's a 4. This is BE squared. What about BE? BE, get rid of the square. You must introduce the square root both sides. So therefore, our BE was going to be the square root of what? This part, x squared plus 2 square root of 2x plus what? Plus 4. This is exactly that we are being asked to show that. So that is exactly what we have shown from this information. Pythagoras theorem. We are taking a right angle triangle, but that right angle triangle, guys, was limited because you are given D to E is X. What about A to D? You must know from the properties of the shape, a square. All sides are equal. So AD is also equal to the square root of 2. If it is equal to the square root of 2, then combine now to have a single side, which is AE, as we have got our triangle ABE. From this triangle ABE, use your Pythagoras theorem. Apply the Pythagoras theorem concept that the hypotenuse is equal to the what? Hypotenuse squared is equal to the sum of the square of the two shorter sides. So that's AB squared plus AE squared. From there, substitute, simplify further. That is how you can play around. And like I said, for the expansion of brackets, instead of you using that binomial expansion of when you square it, you can have two brackets, expand them properly, x plus the square root of 2, another bracket, x plus the square root of 2. So x times x, that's x squared, x times square root of 2, that's the square root of 2 times x. All right, we are done with that one. Square root of 2 times x, that's plus square root of 2 times x. Square root of 2 times square root of 2, that's a 2. Square root of 2 times the square root of 2 is simply like a squared. You are squaring that. You are simply squaring it. So it gives us a 2. So that is going to be x squared, collecting the like terms. Square root of 2 plus square root of 2. There is a 1 here, a coefficient 1. There is a 1 here. So that must be added, the coefficient. Remember from your sets, the square root of 2 plus the square root of 2, there's a coefficient here. 1 plus 1, that's 2 square root of 2. But there is x. So it's going to be 1 plus 1, which is 2 square root of 2. Then you put your x. That's how you add. Please be very careful when adding those sets, the numbers under the square root. Square root of 3 plus the square root of 3 is equal to 2 square root of 3. you add this one, the coefficient. There's a 1 here, there's a 1. So 1 plus 1, that's a 2. The square root remains as it is, just like x. So the square root of 2 and x do not change. This one, square root of 2 and x, this one, do not change. What you focus on are the coefficient. This 1 and this 1, you add them. 1 plus 1, that's a 2. So that was it. As you can see, you're going to obtain exactly the same as what you obtained before from that expansion. So it's either you expand, guys, expansion of brackets, the way that you've been expanding your brackets, the way that you've been taught in class, use that, or just consider also the binomial expansion of a square, the square of a what? Of a binomial. The square of that. How do you square this? A squared plus what? 2ab plus b squared. Understand all the basics. It's all about the basics. So that was it. In order for you to obtain a total of 50 marks in this revision exam, the test that we had for our June revisions. All right. So do prepare in as much as you can. As you are preparing yourselves for the exam that is ahead of time, understand all the basics, go through the basics as an individual. But that is it, guys. Till we meet again.